If you're working anywhere near enterprise data right now, I mean, whether you're an architect, an engineer, or even an executive trying to get that AI uplift,
Yeah,
we're in the middle of a massive shakeup.
the huge one.
The comfortable era of, the nightly batch load, that scheduled pipeline, it's not just fading away. It is decisively ending.
It's over.
We've got a stack of sources this week that paint a really clear and, frankly, a somewhat alarming picture of what the data engineering mandate is going to be for 2026. So our mission today is pretty straightforward. We're diving deep to pull out the critical need-to-know info. We need to get to the bottom of why legacy infrastructure is failing this AI challenge and what the 5 critical strategic shifts are to fix it. This is your shortcut.
And you can feel the urgency here because we're seeing this enormous performance paradox playing out right now. Organizations have thrown, just tremendous resources at Gen AI through 2025. Our data shows 79% of senior execs are already reporting AI agents deployed in some capacity.
79%.
And yet, the results, the financial results, they're just not there. Only 15% of AI decision makers can point to actual measurable EBITDA improvements.
Wow. That is a staggering disconnect. You hear about GPT-5 doing these amazing things, and the models are incredible. They're not the problem here.
No.
The problem, like you said, is that fragile foundation underneath them. It's the plumbing, the infrastructure that's supposed to be supplying the context. And that foundation is just, it's cracked.
It is cracked, and it's proving to be incredibly expensive. Companies are forecasting this astronomical 171% return on these complex AI deployments. But then you look at what's actually happening. Forrester is predicting that a full quarter, 25% of planned AI spending is going to be delayed, pushed all the way into 2027.
Just to fix the basics.
Just to fix the foundations. Data infrastructure is, without a doubt, the bottleneck to AI success right now.
Okay, let's unpack this then. We have to start with the most immediate technical mandate, which is prediction number 1, the end of latency tolerance. We are shifting to a real-time imperative, and it's being driven entirely by RAG.
Right.
Retrieval-Augmented Generation, RAG. This is the architecture that, 71% of Gen AI adopters are using? It's the smart way to connect those big, powerful LLMs with your own private proprietary data.
All your internal stuff. Yeah.
All the stuff in your databases and documents that makes the AI aware of your business, not just the internet.
But the problem RA creates, and it's a huge one, is that it demands immediate, fresh context. Imagine a financial compliance agent, using RAG to check real-time transactions.
Or inventory management.
Or inventory management, exactly. If the data feeding that system is stale, and even 30 minutes old, the model spits out inaccurate, outdated, or just plain dangerous answers.
It's the old model of batch pipelines where latency is measured in hours or minutes.
Yeah.
It's just obsolete.
Fundamentally obsolete for these high-stakes use cases. We have to move faster than a human can even make a decision.
So we are officially hanging up the phone on that classic, painful moment where you realize the dashboard is hours old. This is now a non-negotiable baseline. So for the data engineer, what does this actually mean? What are the capabilities they have to get right now?
Okay, so it's 2 massive technical shifts. First, change data capture, or CDC, is now mandatory for pretty much all critical pipelines.
Right.
This is all about mastering continuous streaming platforms, Kafka, Flink, whatever your tool is, to capture database changes the instant they happen. No more waiting.
And the second one is a huge computational lift in-flight embedding generation.
Exactly. This is the really critical piece. You can't just sync the data anymore. You're no longer allowed to generate your vector embeddings after the data lands somewhere.
That's too slow.
Way too slow. That introduces unacceptable latency. The compute has to happen while the data is moving. You have to integrate model APIs directly into that CDC process, so you're generating context in motion. The vector database has to be updated within seconds of the source application.
What stands out to me there is just the sheer complexity. If you're trying to keep a source app, a streaming platform, an embedding model, and a vector store all in perfect sync, the chances for error just multiply.
They multiply exponentially. A tiny lag, just a few seconds of desynchronization between the source and the vector index, and you immediately compromise search accuracy. That's where you get hallucinations or just, bad results from the RAG system.
So vector data modeling is now a core competency. It's not a niche skill anymore.
Not at all. It's right up there with relational modeling.
Okay, so that speed mandate solves latency, but that rapid, potentially ungoverned data flow creates a massive headache around trust and quality.
Right.
If data is moving that fast, how can you even trust it?
Percent.
And this brings us perfectly to prediction number 2. This is where it gets really interesting. Governance is shifting from like a technical concern to a full-on legal mandate. We're talking about data contracts becoming mandatory policy.
This is being driven by a really painful financial and regulatory reality. When those AI projects fail to deliver that 171% ROI, the first place everyone looks is data quality.
Of course.
And then you add the external pressure. You have things like the EU AI Act, which can levy these massive fines up to $40 million for quality failures. So data contracts become these formal, organization-wide specs that define schema, quality, and consistency for every single pipeline.
A formal contract sounds great, but if we're moving data instantly with CDC, how do you enforce it in real time? What are the, say, 3 big implementation shifts needed?
Right, so you have to shift the enforcement left. First, you need shift left quality enforcement. The validation tests can't be run by a downstream team anymore. They have to be integrated right into the application developer's CI/CD pipeline.
So you stop bad data before it's even created.
Exactly. Prevent it from ever being produced.
Which sounds great for quality, but doesn't that slow down application development? I mean, if every app team now has to own data quality enforcement.
That's the tension, yeah. And it forces better engineering upstream. Second, you have to have rigid schema enforcement at ingestion. This is where platforms like Delta Lake become essential because they guarantee that structure and prevent schema drift.
Which is lethal for LLMs.
Absolutely lethal for LLMs that need stable context. And the third shift is the automated quarantine mechanism. Instead of letting a bad record break a critical pipeline, the tooling has to automatically flag it and quarantine it for review. This protects the downstream systems, prevents what we call silent loss of data integrity.
It's proactive enforcement, not just passive monitoring.
Exactly.
And that proactive governance becomes absolutely essential when you look at prediction number 3, which is the fragmentation that happened during the 2025 AI gold rush.
Yeah.
You mentioned agent adoption went through the roof.
Yeah.
What was the result?
The result is what we're calling the agent late phenomenon. Companies just rush to deploy all these best-of-breed AI agents from different vendors, one for sales, one for customer service, another for engineering.
What a total mess.
A total fragmentation nightmare. Because now these agents all need to talk to each other, but they use different APIs, different security protocols, and they often rely on slightly different data sources.
So the data engineering team now has to take on AgentOps and LLNA just to manage this whole ecosystem. What's the key architectural piece that's emerging to solve this chaos?
It's the Model Context Protocol, or MCP, server. We're predicting 30% of enterprise vendors will launch their own version of this by 2026.
Okay, so what is an MCP server?
Think of it as a really sophisticated, standardized API gateway. It's designed to manage, orchestrate, and crucially, secure all these complex, multi-step requests between all the different agents. Data engineers will be the ones managing the traffic across these servers.
And that immediately sets off huge security alarm bells for me. If you have an automated agent that can execute transactions or access sensitive data, and it's talking to other agents, the potential for a breach is enormous.
The security stakes have been elevated exponentially. I mean, agents can exfiltrate massive amounts of data or perform unauthorized transactions way faster than any human could ever detect.
So what's the defense?
It demands a radical shift to fine-grained, context-aware security. We're talking pure zero-trust principles applied deep inside the LLM app's pipeline. Everything has to rely on token-based authentication and real-time metadata to dictate exactly how and when an agent can touch a piece of data.
Let's shift gears a bit. Let's talk about prediction number 4, which is about the role of the engineer itself. It's this idea of the automation paradox. Gartner's predicting that 60% of data management tasks like generating ETL, inferring schemas, will be automated by AI by 2027. So is the data engineer getting replaced by a script?
You know, it's fascinating because that is the immediate fear, but what we're actually seeing is the total opposite. The role is absolutely being elevated, not replaced.
Elevated how?
AI becomes this incredibly effective co-pilot. It handles all the tedious, repetitive stuff that used to eat up 80% of an engineer's day. So the engineer shifts away from manually coding pipeline A to pipeline B, and instead focuses on validating the correctness, the compliance, and the cost efficiency of the AI-generated logic.
So the value moves from just brute force coding to nuanced judgment. What does an engineer actually do all day when an LLM writes 60% of their code?
Their time is spent solving much higher order problems. They have to have the architectural chops to debug this complex, sometimes opaque, auto-generated logic. They're focusing on cost optimization, making sure the AI's pipeline doesn't cost 10 times more to run than a human's.
They become a product owner.
They're acting as the product owner, exactly, making sure it meets the business outcome and the data contract, not just that the code compiles. The most valuable skills are still architectural design, advanced data modeling, and deep SQL mastery. Understanding the why behind the data flow.
So it's a shift from being a doer to being a system architect and a guarantor.
Yeah.
That complexity and the need for unified governance across all these different systems, streaming, vectors, agents, it all points to our final prediction. Number 5, lakehouse architecture consolidation. The lakehouse has always had its critics, people saying it's too complex compared to a traditional warehouse. Why is it suddenly cementing its place as the default foundation for 2026?
Well, because it's really the only architecture that can successfully unify all the diverse data formats that Gen AI needs. You need your structured transactional data, you need unstructured documents and videos, and now you desperately need this high-velocity vector data.
Right.
The lakehouse gives you a single governance layer that can handle all three. It can support batch, streaming, historical analysis, and AI workloads without all that costly, messy data movement.
But there's another driver too, isn't there?
There is, and it's a massive one. Distributed data. We're projecting that 75% of all enterprise data will soon reside at the edge, on IoT devices, sensors, remote retail systems.
So if 75% of your data isn't even in your central cloud platform, how does the lakehouse manage that?
The central cloud lakehouse becomes the single point of governance and aggregation. Data architects now have to design these incredibly sophisticated synchronization strategies to ingest all that edge data and maintain what we call eventual consistency across the entire enterprise.
So you're pushing intelligence out to the edge.
You're pushing compute closer to the source and then designing asynchronous pipelines to federate that context back to the central lakehouse for AI to access. It's a complete reversal of the old centralized model.
The roadmap for 2026 is becoming crystal clear through these 5 shifts. The comfortable era of slow data is definitely over.
Yeah.
The conclusion we're drawing from all our sources is that 2026 really is the moment of truth for enterprise AI. We've been through the hype cycle, and now we're facing the reality, which is that success hinges entirely on data engineering maturity.
100%.
Pivoting from slow, batch-oriented storage to these fast, governed, real-time context delivery systems.
So for you, the listener, here's the readiness roadmap. It really boils down to 3 critical areas you need to be investing in right now.
Okay.
First, you have to master AI infrastructure. And this is more than just simple Python scripts. We're talking a true understanding of vector data modeling, deep LMOps, and AgentOps. That includes getting good at asynchronous programming frameworks,
Which are essential for these new real-time apps.
absolutely essential. Second, you have to standardize on streaming infrastructure. This is just non-negotiable. Move all your critical pipelines, especially the RAG feeds off legacy batch ETL, and onto high-throughput CDC platforms that can do that in-flight embedding generation.
And
finally, prioritize automated governance tooling. You have to invest in platforms that enable AI-driven compliance, anomaly detection, and mandatory data contract enforcement that's shifted all the way to the left. To the source.
Like where the data's born.
Exactly. So what does this all really mean? We've laid out the 5 shifts, the urgent mandate for engineers and architects. It's clearly not about supporting some side project anymore. It's about supporting the entire business model in an AI-driven world. The final thought for you to consider, which I think really captures the stakes here, is this. The question is no longer whether your data infrastructure can support AI. It's whether it can support your business in an AI-accelerated world.